Hello and welcome again to my channel. We're on day number 5 of the PiHut Maker Advent Calendar. So let's get box number 5 open and let's see what we've got in there today. So, box number 5. In this box you will find a buzzer. Custom pre-wired buzzer with male jumper wire ends. Today's project will be using our buzzer in a few different ways. The first for simple beeps and tones, then combining with our potentimeter to control the volume. Then finally something a little more advanced where we use different frequencies to generate festive tones. This particular buzzer works with PWM signals to allow you to generate different tones. So we'll be tapping back into everything we learned about PWM in yesterday's box. We'll be using the potentimeter from yesterday's box to control our buzzer in a few moments. So leave your circuit in place as it is. We just need to add the buzzer and we're good to go. This is one of the easier components to work with as we've included a custom pre-wired buzzer with male jumper wire ends. Simply push the red wire into GPIO 13 and the black wire into the ground pin next to it, physical pin 18. So physical pins 17 for the red, 18 for the black. Activity 1, let's buzz. Our buzzer can generate different tones based on the PWM frequency and duty cycle we use in our code. This should sound familiar as we covered PWM yesterday. PWM frequency and duty cycle with buzzers. The frequency here changes the tone of the buzzer. We find that our ears can detect changes in the tone when using values between 10 and 10,000. The duty cycle sets the volume of the buzzer. The range is technically 0 to 65,535 in MicroPython. However, we find that values below 5,000 are very difficult for our ears to hear. A duty of 10,000 appears to be the sweet spot for our buzzer. If you want to silence the buzzer in your code, just set the duty to 0. Easy. So, now we know what the PWM values do here. Let's try a quick example where we sound the buzzer for a few seconds. The example below includes the same ingredients you're now becoming familiar with. Imports, pin setup, PWM duty cycle, and frequency. So there's nothing new or scary here, and our usual slightly excessive code commentary tells us what each line is doing. We set up the pin for the buzzer, then assign a frequency 1000, and finally set the PWM duty volume to 10,002 for a second, and then back down to 0 to mute it. Nice and easy. Copy the example over to Thonny and give it a go. Paste. Plug the Pico in. There's our connection tone. Okay, and let's run. That sounds like an old computer beeping. Now try changing that frequency under 300 and see what happens. Let's change it to 100. Oh yeah. Did the tone go lower? You can try higher values too, but eventually you'll go too high, around 10,000, it won't work on human ears, don't hear it. So let's try 9,000. Cool. Just about hear it. Okay, activity 2, changing tones. Here's another simple example just to show you how easy it is to change the tone on your buzzer from one to another. Here we start with a frequency of 1000 for 1 second and then drop it down to 500 for 1 second. Give it a try here yourself. So let's change it from 500 to 5,000. Cool, yeah, that went the other way. Activity number 3, potentimeter volume control. Let's use one of the previous components to control the volume of the buzzer. This one's a bit noisy and not perfect. The sound can distort or cut out at high levels, but it's a fun project to try out. If you find the buzzer a bit loud or harsh, you can always place some sticky tape or a blob of blue tack over the hole to calm it down. The readings from the potentiometer are between 0 and 65,535, and our buzzer duty volume uses the same range, so we can use the potentiometer readings to directly control the duty. So in the example below, in the while loop, we take a reading from the potentiometer and store it in a variable called reading, and then we use this variable as the buzzer duty value. Let's copy the code, place it in here, and run it. Okay, so let's use this to turn up the volume. Wow. There we go, and down again. There we go. Okay, I'm just going to copy the other code just to stop it buzzing. There we go. That killed the buzzer. Okay, so activity number 4, festive jingle. How about a little festive tune with our buzzer? By changing the frequency between each pause, we can create a tune that resembles a popular festive jingle. A nice way of doing this is to define each musical note frequency as a variable using the note name, which will make our code easier to write. A nice way of doing this is to define each musical note frequency as a variable using the note name, which will make our code easier to write, read and review. We've covered variables before, so this should be familiar. We've also used a variable for the volume, as again it makes our code a little more human. Don't worry, we've included the tone values for the jingle below for you. The example below is purposely inefficient and uses a lot of lines, mostly because each section of the jingle includes lines to turn the volume on and then off, as well as delays. Try this first and then we'll move on to a nicer way of doing things in the next activity. We've included commentary on the first jingle block of code so you should know what you're doing here. Paste that in and then run. Excellent. Jingle bells, jingle all the way. Okay, so activity number 5, festive jingle using functions. Let's improve the very long code above by introducing something new, functions. Functions are blocks of code that you can create and call at any time in your program. They're great for repetitive blocks of code, as it keeps your program short and efficient. Let's explain how functions work before we move on. Below is an example of a simple function that prints 3 lines. We create a function by writing def followed by a space, and then the name we want to give our function. We've called ours my function. You then add brackets at the end, which include any arguments if required. Indentation is important again here. Everything under the def line must be indented to indicate that it's part of the function. So now that we have a function, how do we use it? And why is it better than just writing the code? We can call the function by simply using the function name followed by the brackets like this. My function, open close brackets. So why is this better? Let's look at two examples below where we want to print a set of strings 3 times. Both the following examples have the exact same outcome. Try them yourself. However, the code using functions is shorter. It might not look like much in this example. However, in large projects, this can save a lot of lines in your code. It also makes it a lot easier to update your code as you only have to amend the one function and not every part of your code. Example without the function. This is a print. This is a function. This is a function. And then with the code. Now with the function. So it's repeated it 3 times, just like it did before. We have saved 2 lines of code. With that, 3 lines of code. We mentioned arguments earlier, so let's talk about them quickly before we get into our jingle example. Arguments are optional in functions. They allow you to pass information into your function if needed. We pass the information to the function when we call it. That might be a bit confusing, so let's jump to an example so you can see it working. In this example below, our function prints 3 lines again, but this time we include arguments asking for the first name, middle name, and surname, as we might want to change the names each time we call this function. Those arguments are used in the print lines, as you can see below. So let's copy this, paste in so we can get an idea of how that's running. Okay, now to call the function and pass the names onto it. We add the names in the same place inside the brackets. Okay, yeah. Okay, try this yourself, then try adding a 4th argument and printing a 4th line to go with it. Okay, so we could do print age, comma, 40, here we go, 4th line added. Now we know how the function works, let's apply them to our jingle example to see if we can reduce the length of the code. The example below uses a function called playtone to handle all the volume changes, delays and notes. All you have to do is add the arguments for each. Our arguments are note, the note to use, vol, the volume, delay 1, the first time sleep period, delay 2, the second time sleep period. The code is roughly half the number of lines and does the same thing much better. So let's copy, paste. Excellent. Okay, so we've got here in our code, create our library of tone variables for jingle bells. So these are all the notes used in jingle bells. The volume is set by the duty cycle. And then we've got our note volume delay. Jingle bells, jingle bells, jingle all the way. And then turns it off. So there's a bonus on this activity that there's even more notes available for us. So it says, Chris E. kindly added a comment below providing a nice full list of notes, including sharps. Look up your favorite songs and use these notes to get creative. Ah, yes, I think I'm going to do that. Day 5 complete. We've covered lots today, fellow makers. Pat yourselves on the back. As we cover more advanced topics such as functions, you may find that you need to refer back to these days to refresh your memory later on. And that's absolutely normal. Even the most seasoned professional programmers have to use search engines regularly. So what did we cover on day 5? We built a circuit with a buzzer with our first audio component. We learned how to use the buzzer with MicroPython, and the Pico learned about PWM frequencies and duty cycles with buzzers. Used analog inputs to control audio volume using PWM, created a festive jingle with MicroPython, learned how to use functions to make your code easier to manage and more efficient. Again, keep our circuit safe somewhere until tomorrow and don't take anything apart just yet. There we have it. Day number 5. Looking forward to day number 6. See you tomorrow.